So today I'm going to introduce new chapter. It's a measuring and controlling for quality chapter, which is another very important subjects in quality control course. Okay, in whichever institution you study this subject, whichever level you study these subjects, usually this control part is pretty big in terms of the entire course. So this is my plan. I tried to finish these two today. Mostly we're talking about the measurement issue today, and then for next whole week I'm going to reserve it for the statistical process control. Okay, and then we may spend one more week to kind of review and reinforce what we have learned in this chapter. So overall I'm just planning to take 2 weeks to finish. So let's first take a look at the big picture. So whichever level that you're planning, right, it could be strategic, which typically is very high level and long-range planning. It could be mid-level, you're planning for operation or you're planning for the execution. Regardless of which level of planning, it is very important to ensure executions are well monitored and your outcomes are accurately measured. So you know why? So usually when we talk about the management, it is about 4 different actions. You plan it, and then you do it, and then you always want to check it to make sure whether things are going okay. Okay, so that is actually one very important key in the management paradigm. So how do you check whether things are going all right? Okay, so you come up with this beautiful plan or prototype, you want to make it, you want to execute it, but if you lost track of it, or if you don't have a effective way of measuring whether it is on course or within control, and it is going to be very difficult to assess whether your plan is sound or not. Okay, so in the quality control area, whenever we say check, it has a strong strong taste of checking the quality of product after it is being made. Okay, however, Deming famously advocated for more in-process inspection. Okay, in-process inspection. So Deming wanted to use in-process inspection as a way to gather information about the current manufacturing process, whether it is going okay, whether it is behaving beyond expectation or things like that. Okay, whenever you do after process inspection, things may already gone wrong. Okay, so again, the key here is we'd like to exercise whenever it is possible or whenever it is economic to do that, we do in-process inspection. Okay, so this new role of inspection has been integrated into the quality management practice for most companies, but here, the complication here is that field managers truly understand the variation in production and how to leverage in-process data for improvement. So this particular chapter deals with that particular issue, how to help you understand by reading the data generated by your process to learn whether your system is actually under control or not. That is very important. Okay, so briefly talk about this cost that's related to the quality. Whenever there is a quality issue, it incurs some cost. Okay, so to prevent bigger costs that is happening from the later phase of manufacturing, we'd like to do some kind of arrangement. The things like prevention, things like appraisal. Okay, and these two things are related to actually preventing the quality issues from happening in the later phase. And then we are seeing the internal failure, right? Things like those components that had to be sent back for rework, these are considered as internal failure. Whatever failure that is related to quality happens before the product is shipped to the customer, we call it as internal failure. Whatever things happen after it is being shipped to the customer, we call it as external failure. So if you think about that, these are the common items under each category. You can review carefully. Okay, you can review carefully, and this is usually very favorite for the teachers because it's very easier is because it's very easy to make some multiple choice type of questions out of this list. Okay, so make sure you understand this part. So section 1, it's about the measurement. Okay, first it's about the measurement. So measurement is very important, because if you cannot measure effectively, you cannot control properly. Okay, how do you expect to learn what is happening here by looking at the data that is wrong? Okay, there could be many sources of error, but the fundamental idea here is that we'd like to control a lot of errors during the measurement phase to minimum. Okay, so again, this is an act of collecting data to quantify the value of product, service, processes, and other business metrics. So measurement is an act. Measures and indicators can be some kind of numbers that calculated using simple, formulas. Okay, I think you probably heard about something called a KPI, right? Key Performance Indicator. So these are the indicators. Okay, it's very simple, that captures the current state of something. You probably have heard about Process Capability Index from 3020. We're going to revisit that a little bit here, but in a greater detail. So here's an idea. So how do you measure your quality? So this is an example of pizza fulfillment process. You have a customer, you have a order taker, you have a cook, you have a driver, you also have a customer who's receiving it. I think this is customer ordering it. So many different roles, many things can happen that will cause quality issue. So customer will place, these are the actions, right? You draw using a flow chart, so you can evaluate possible quality issues may happen in each phase. So you need to implement some of the measurement to come up with measures or indicators that can help you understand what is happening in our store, in our overall chain, something like that. I hope you heard about something called a dashboard. Okay, dashboard tells you the current state. So these things, the percentage of costs placed on hold, percentage of accurate orders, percentage of pizzas rejected, average daily time to delivery, number of errors per week in collection, daily raw material inventory. These are all quality measures that can assess different areas of your business in terms of quality. Okay, so these can be measured in percentage. Sometimes they can be measured as a number or time. Okay, so let's first review I think I skipped. Yeah, I think I should move this to the earlier slides, but the chance that when you see this slides from the blackboard, this will be moved to the proper location. Okay, so the common quality measurement, the way we measure quality, the type of way we use to measure the quality is largely two different types. One is called attribute measurement. The other one is called variable measurement. Simply put, the attribute measurement usually measure things by whether or not. Okay, 0 and 1. So if you think about the third assignment I gave you, the first problem, I told you to come up with the proportion of defects. Okay, so initially you got the data that is in numbers, 13.4, 13.5, things like that. However, I showed you how to convert those into 0 and 1 measure. Okay, I wanted to convert that into attribute measurement. Okay, so again, the attribute measurement is usually measured by whether or not. Therefore, you can simply document it using 0 and 1. If it's no, it's a yes. If it's no, it's 0. If it's yes, it's going to be 1. You document in that way. And presence or absence of non-conformance in a unit of work. So if you just visually inspect certain thing, if you sense that this thing have a defect, you put it as a 1. Okay, if you after the visual inspection you did not find any defects, you can just simply make it as a 0. Okay. However, in variable measurement, things are more complicated. You measure it by using the actual quality dimension, things like length, weight, amount of time, things like that. So instead of using 0 and 1, we're using the actual quality dimension. 13.5, amount of time taken is 187 seconds, or things like that, are all considered as variable measurement. So variable measurement is usually more sophisticated to capture correctly, where the attribute measurement is easier, it's more simple to capture it, to measure it. Okay, but usually variable measurement is more useful. It tells you more information about the system when attribute measurement is not. Okay, and then let's go back to this example. Can you identify what type of measurement are these? So you can pause for a second and see if you can identify the variable measurement from the attribute measurement. Okay. So yeah, so simply there's no correct answer here, okay? But these are certainly attribute measure, the percentage, the proportion of rooms, proportion of freight, percentage of times. These are certainly the attribute measurement because the basis will be 101010. Okay, whether you're satisfied or not, right? Whether you're satisfied or not, yes and no, right? However, these response time, time of delivery, and billing accuracy, I don't know how they exactly measure this, but these could be variable measures. Okay, hope this is clear for you. The reason why we distinguish variable with attribute from statistical perspective, these rely on different type of different type of distribution to calculate the probability. So these will become very important when we start to discuss the statistical process control later. So again, here are two examples. You can take a look. So in hotel, 35 rooms were inspected and 3 rooms were found to have non-conformances. 1 room had 1 conformance, and the second had 3 conformances, and the third had 2 conformances. Okay, so don't use the formula. The formula is already here. So the proportion non-conforming, so it's 3/35. Okay, so this is a proportion non-conforming. The target here, the main thing we'd like to analyze here is a room level. However, here non-conformance per unit is total number of non-conformance with the number of unit inspected. So this tells you, I think the calculation here is wrong. I didn't have time to review, so there's some mistake here. Let me do it again. So here, this one is much higher at 0.17. Okay, 0.17. So this is a non-conformance per unit. So you can expect each room has this number of non-conformance. Okay, so let's move on. And this is a concept that's often discussed in quality management. We call it as a DPMO, shortly put, DPMO. So defect per million opportunities. So basically, this is the probability, and you multiply by 1 million. So sometimes the probability number is very small. It's very difficult to sense or feel the magnitude of the defects. Okay, so yeah, here is in service industry, you call it as errors per million opportunities. But overall, the idea is to calculate how many mistakes you'll be making or how many defects you'll be generating out of each million products you are making or over every 1 million opportunity to serve customers. So here's an example. I'm gonna finalize this video here, but before you switch to next video, please take a look at this example yourself and see if you can solve it. Okay? I think I may have enough time to solve it. Okay, let's take a look. So you have 3 package that's lost. Come on, I'm losing time. So you have a 1.6 for each customer. You had 8,000 customers. 3. What is it? Okay, that is the answer for this one.